just going to go through basically some relatively high level things about sort of the previous year and where the technology is and how GIS has been applied. I'll just pick out a few interesting points. And then we've got a 10-minute demo as well of a recent project we did highlighting digital twins and the role of GIS within those. So obviously we all know that we're in a threatened world at the moment, threatened by our own activities in many cases. And there's a lot that we need to do to create a more sustainable world that we can hand on to our kids and ourselves and so on. And GIS is absolutely central to helping the planet, helping society understand the impact of climate change, mitigate against it, plan better, try and do more to protect our environment and communicate that. And GIS is in a unique position to help with that process. It already is being, but we need to do more on it. But really, really important in all of this, obviously, is, sorry, just trying to work out why my screen, there we go. The work that you do as a GIS community is absolutely vital, because if you want to understand a complex planet and what's happening on it and the impact of our activities, you need a way of pulling together multiple sets of information, synthesizing those sets of information, analyzing them and communicating the results, understanding the results and communicating them, and then taking action. That is almost a description of what GIS is. And that's what GIS professionals enable. And we're doing a lot in this area. However, I feel we're not doing enough yet. We are struggling to communicate the potential for the technology and the ability to use it and how to use it. We're at a better stage than we've ever been, but we need to do more than just have technology. We need to be better at communicating what is possible and how to do it. It's been an interesting year. I mean, it would be hard to go through that talking about the response to COVID. We've seen the application of GIS to this, and that's helped massively with the communication of the potential. There's a project here on the left called Virus Watch. This is where we worked with University College London at Esri, and we helped them on a project to track people in the community. So they had about 30,000 people sign up to the project. A few thousand of them agreed to be tracked 24/7 down to a meter resolution. And the idea of the project was to try and understand how COVID spreads in the community beyond hospitals. So it ran for a year, and we had just this incredible level of information that showed where people were, but also their response to things. So if a lockdown is announced, people travel more, and then after the lockdown kicks in, they definitely do settle down. When they get vaccinated, they think they're super people and head off around the country again, and so on. And it was just an interesting project because the amount of data we captured was vast. But the team working on the Virus Watch study, they almost didn't know what to do with the geographic component, and it revealed stuff that they just hadn't even considered, and they were able to learn more than they thought they were going to learn from the project because of the addition of that geographic component. And that was an interesting process. Obviously, dashboards have been very successful in communicating the impact of COVID in Wales and around the world. And we've seen usage levels that we never considered we would get to the usage levels that we see. We're seeing trillions of hits on various dashboards around the world. And the idea that you can take a data set, publish it, and make it available to a planet's worth of people who can ask questions of it and make decisions based on it at really, really vanishingly low cost in the scale of things is a real change in what's possible in terms of the publishing and sharing and communicating geographic information. Another area that we're seeing a lot of work in is sustainability, and it's a vitally important piece of work. And one role that GIS plays in this, I'll show you. This is an application that our education team at Esri UK put together, where we worked with the Met Office and took their climate data, which is complex data and global in nature often, and we put it into a format where school kids at different ages could understand the data in the context of themselves. So it's fine hearing about global warming, but what people really care about is themselves. They care about their families, they care about their houses, they care about the impact on them. And we need to translate global effects into personal effects so that people understand the implications of it and what they need to do about it. So we created a series of applications that took the Met Office's very complex information and put it in a format where people could interact with it and ask questions of it. So this map just shows temperature projections across the UK under different scenarios. So if we manage to mitigate climate change significantly, we get one set of figures, and if we don't, we get another set of figures. We can look at the summer and winter impacts and so on. It's just a really interesting way of exploring the data. But what people normally do is they look at where they are, and they ask questions of where they are. Geography, GIS, makes data, makes decisions, makes information relevant to people, and it helps communicate it. And that's a really important process and something we need to bear in mind. This little link here is to a study, a really interesting case study on, there was a firm in the Peruvian Amazon who created a fund to do sustainable cocoa bean plantations. And the idea was they would buy up degraded farmland in the Amazon, and they would plant more sustainable cocoa beans, and they would improve the overall environment. And it attracted millions of pounds of investment because it was a really interesting project. A researcher in South America saw this, felt there was something wrong with it, and used free tools to basically go on the internet, used ArcGIS Online, went back in time with satellite data, Landsat data, used analysis tools and change detection, and proved that they had bought virgin forest and clear-felled the lot before they planted the cocoa beans. And as a result, some of the people from that company are now in jail in South America. That to me is a really interesting way of where geography and GIS and the techniques applied to it are being applied to holding organizations to account, to auditing how we're working with our planet. And we're starting to see that use increase. And the information that was produced was so visually compelling and so hard to refute that it stood up in a court of law. Once again, this is the role of GIS, and the role of geographers and people who work with GIS is to help communicate complex issues. ArcGIS itself has had an interesting year. We've done lots of developments. Every single thing on this slide, we'll share the slides afterwards. I'm not going to go through them all, but everything on this slide has had active development through this year and advances in capabilities. So GeoAI machine learning is just racing ahead in capability. I was just looking at some of the new stuff last night that we're working on, and there's a lot of work going into using AI to track things and take information and build sort of, basically where people have been, where vehicles have been, where they might be, to predict where they might be in the future, to take scant information and build it into something that gives you sort of more intelligence. And it raises lots of interesting questions around data ethics and privacy. That's something that we need to be very conscious of as a community. And we're putting a lot of work into data ethics and location data ethics in particular. Other interesting things is the rollout of cloud computing, ArcGIS Online, and the use of cloud native capabilities has sort of expanded massively through this year as well. And that's another interesting area. 3D is a really, really sort of, it's just becoming sort of a normal way of doing GIS. And on that one, let's skip ahead to reality capture. So we've seen a real advance in reality capture. I'm just going to show you a few examples of this, where it's just easier than ever to capture information. This is so we have a product that's going to be released next year called ArcGIS Reality, and it is an engine for turning various types of imagery into 3D meshes and then providing them for analysis. But it's not just for city sort of scapes that you normally see. This is one of I think it's in the Dolomites actually, and when it loads in, you can see the incredible level of detail that can be captured just by flying a drone over something and then processing it in a way that can handle the geometries. And if you're a geologist, some of this thing, if I go to this slide, for example, you can see the grain of the rock. You can start telling things about the processes that formed this rock. You can look at erosion levels. You can look at avalanche risk. You can look at incredible amounts of detail. Let's let that load in. My per machine is struggling here. I'll just zip over to South America. There's a mine in South America that produces minerals which are used in renewable in battery technology. And this drone has flown over this site, and it shows the volume of investing in a battery technology plant, and you want to make sure your supply chain, one, has enough material to supply you, but two, is in an area where human rights are being protected. So you can look at your supply chain and tell whether it's a viable one. You can tell whether it's a resilient supply chain, but you can also tell whether it's an ethical supply chain. But you can measure in great detail exactly what type of mineral is here, the volume of it, and everything else, just by flying a drone over it and processing it. And that's just an incredible advance. And we're seeing, you've probably heard people talking about digital twins. I think people in the geographic world get a bit frustrated because we've been working with digital twins for our entire careers. It's what GIS does to a large degree. But we're seeing real interest in digital twin technology being used to model the real world and to ask questions of complex systems to say, what's the impact of this decision on this system? And once again, GIS has a role in taking disparate digital twins, like systems from electricity companies and water companies and soil systems and so on, and bringing them together into one coherent system simply by looking at their relative locations so that we can ask questions of them. And what we're about to show you is a video we put together to demonstrate the national digital twin and the concepts behind it. We worked with some really interesting people and created this demo. So I'm just going to hand over virtually to Claire and Richard, who will take you through the work that we've done.
Thanks, Charles. We're in the midst of a climate emergency. Over the coming years, we'll all feel its effects, and many people in the world already are. And whilst tackling this challenge spans across every aspect of our lives, we also believe that GIS plays a crucial role in understanding and mitigating the impacts of climate change. Let me give you just one example. Our towns and cities are kept running thanks to a vast array of utility networks. They provide us with everything from water to drink to the electricity that powers our hospitals. But with climate change making extreme weather more frequent, these networks are increasingly susceptible to damage and outages. Losing services during extreme weather is a serious matter that can hinder recovery efforts and cost lives. Not only that, but the interconnected nature of these utilities makes cascading failures a real possibility when we look at future climate predictions. The National Digital Twin Programme aims to mitigate these risks by building a connected digital twin that will give us a system-wide view of our country's infrastructure. By collaborating and sharing data across industries, we can increase our resilience in the most efficient and effective way possible. COP26 was the perfect opportunity to present the National Digital Twin Programme's Climate Resilience Demonstrator, or CREDO, to the world. We were tasked to create a public demonstrator app to help share the vision of CREDO. The app had to be simple to use, work across all different devices, and most importantly, communicate the importance of digital twins in the realm of climate resilience. We used ArcGIS Experience Builder to create an app that offered a bespoke and tailored user experience. But at the same time, being hosted in ArcGIS Online, this custom app didn't need to sacrifice any of the simple scalability and robustness that we've really come to depend on over the past few years. We really were able to have an app premiere at an international conference and not have to worry about the surge of traffic it would receive. This left us free to focus on the most important thing: telling the story of CREDO. We'd love to show you the app now, so I'll hand you over to Claire to take you through it.
Thanks, Richard. Let's step through the app together and discover how we can make important decisions to address infrastructure resilience in the face of the climate emergency using connected digital twins. First, the app sets the scene with an animation created in ArcGIS Pro. Let's find out what unfolds in the fictional Sunford City as Storm Ruby sweeps through.
After a series of recent storms, Sunford Park is recovering from localised utility outages. Repairs were ongoing but have now been postponed as Storm Ruby approaches. As the storm hits the city, heavy rainfall causes the river to flood in parts of Sunford Park. Local telecoms are damaged, making reporting and response difficult. Large areas of the city are without power, as distribution and primary substations are damaged. The power outage also brings down a wastewater pumping station, causing sewage to flood into the homes of Sunford residents. As the evening approaches, flood levels begin to recede, and recovery efforts can increase. Several utilities are able to recover using temporary measures. Recovery efforts continue into the morning of the second day. However, by midday, a storm surge combines with high river flows and floods to a new area of the city. This flood brings down a primary substation, causing a general power outage, severe telecoms disruption, and a disrupted freshwater supply. By the end of day 2, Sunford Park Hospital is suffering from communication and water outages, and vulnerable households have been left without services. The storm that hit Sunford City was unprecedented, but a changing climate makes such events more likely. Understanding the interconnected infrastructure system networks that serve our towns and cities can help us prepare for extreme weather and flooding and adapt to climate change. Through CREDO, the National Digital Twin Programme is creating a demonstration of how this is possible.
With an understanding of the crisis we now face, it's our turn to help Sunford City adapt to climate change. Using data available to us from digital twins, we can make the best decisions that we can. We begin here by playing the role of a resilience planner for the water network. By assessing the information available to us, we can begin to make decisions that provide additional resilience to our infrastructure assets. In the map here, we can see which assets have been taken offline in the storm, outlined in red, and we can interrogate these to understand their function. This asset here in Sunford Park is a wastewater pumping station that pumps sewage away from buildings. And we learnt from the animation that this causes sewage to flood some of the homes here. Further interrogation of the map reveals a hospital, and the additional information tells us that Sunford Hospital is experiencing low pressure or no water. This is due to a clean water booster pumping station failing, as its main function is to pump water at optimal pressure to buildings. We are presented with key information and options available to us that can help add resilience to the water network in Sunford City. For example, option B suggests we could add a dual clean water supply for the hospital to draw water from another point in the network if there were to be a failure. However, choosing this option has no impact on the outcome, and the assets are still offline. When considering why this might be, we can see that we have information missing relating to both the power and the telecom network, but we do know that 49% of buildings are experiencing clean water issues, and 1% of buildings are experiencing sewage flooding. Here, widespread power outages cause the clean water booster pumping station to fail, and so even with an additional water supply point, the asset would ultimately still be without power, and so not able to deliver water at an optimal pressure to end users. Without this key information during planning and decision making, our interventions are limited to the information available to us, and so we fall short of providing a better solution that has far-reaching benefits to infrastructure resiliency and ultimately the protection of homes, businesses and vital services. We can now progress to use a connected digital twin. With the connected digital twin, we now have more information available to us here in the map. We can see more clearly the extent that Storm Ruby has impacted Sunford City's infrastructure, covering water, telecoms and power. We can again interrogate the map and discover more about assets. Here we can see that this substation provides power to distribution substations and other major assets, and it's been taken offline by the storm. One of the assets it serves is this base station, part of the telecoms network that supplies mobile communications to the surrounding area. Considering the view of the water network we saw earlier in the context of this connected digital twin, it's clear that these clean water pumping stations receive power from the substation here in Sidley. And so, to protect water supply to homes, businesses and Sunford Hospital, we need to take action to improve resilience. Again, looking to Sunford Park Hospital, we now know that in addition to the water issues, the hospital is now experiencing external communication disruption. With the options presented to us, I'd like to see the impact of relocating Sidley's primary power substation, so here I'm opting for option A. Right away, I can see that the majority of the assets to the west of Sunford Park are now back in operation. The substation has been relocated from Sidley to Davidston, far from current and future flood prediction zones. Looking at the information provided, we can see that the hospital is now operating as normal. In comparison to making a decision with only information from the water network, we now have information available that helps us determine the overall resilience of the system as a whole. We can see that the clean water booster pumping station, once offline, are now operating, and we have 0% of buildings with no water. However, as we saw previously, the wastewater pumping station in Sunford Park is still not operational, and in general Sunford Park is still experiencing difficulties. And so by modelling interventions using a connected digital twin, we can also determine where we may need to plan for additional interventions. With connected digital twins and cross-sector collaboration, we can review resilience across a network and compare cost and the impact of interventions. Comparing cost to resilience and overall impact allows us to make informed investment decisions for our infrastructure.
That's great, thanks Claire. Working on the Credo project has been a really exciting opportunity. Not only has it helped the National Digital Twin programme drive their vision forward, but for me it's also brought home the power of ArcGIS to help us tackle the challenges of our time. We had just a few short weeks to build the public demonstrator app. Through that time, we brought together disparate datasets, whether they were open, anonymised, or even authored from scratch. We derived links between different utility assets and calculated the impact on individual buildings. We created animations, 2D maps, 3D scenes, and wrapped it all up in a responsive app that told the story to people from all different industries and backgrounds. But perhaps best of all, we did all of this with completely off-the-shelf products. No coding, no server management, just simple configuration. And that's great, because it means that more than ever ArcGIS is being unlocked to anybody who needs to make discoveries or share their stories through the power of geography.